First of all, thanks a lot for the chance to speak here, and like I'm really excited to tell you a bit about like the detection of AI generated texts, and I wanted to speak about this topic, indeed, the how to detect generated texts, with a bit of a like twist on the topic. So I thought about like. Calling it like Textbusters, like like the movie, just to like I don't know, make a small pun here. Um, but this is what we are going to be speaking about. So how to catch AI generated texts. We're going to be dedicating more or less the next 50 minutes to speak about the topic, and it's really interesting. So I really hope that we can all learn something together. And having said that, feel free to like ask questions at any time or at the end, whatever you prefer. Like I have no problem if you just want to like just jump in and ask any questions. And having said that, let's get started.
I will monitor the chat,
Yep.
right? If there is a question in the chat, then I will ask you, right?
Great. That's fantastic. Thank you. Thanks a lot, Frank. Thank you.
Yeah, welcome.
And I just wanted to, like say like a few words on who am I, who's this guy that's speaking here. I'm Aldan Creo, so like that's my name. And I work like with AI and natural language processing. Right now I'm working here in Dublin in Accenture Labs. That's where I work at. And yeah, that's just a super short introduction. I just wanted to say like a little bit who I am. No, so I work in research in artificial intelligence, and while I finish the introduction, I would love to ask you to go to this link here or just scan the QR code, because we're going to have, I'm going to share some links with you so you can access, like the information that we'll be presenting in the slides, and also like some interesting websites. So if you go to this link, it would be great. So I'll just give you like 30 seconds to scan the thing, and then we're really gonna get started. So I hope you've had a chance to scan the thing. And now, having said that, I'm just going to have a few words on the structure that we will be following here in this presentation. So we're going to be speaking indeed about how to catch generated texts, and we're going to be doing this in 4 steps. So first, I'm going to just give like 3 minutes to explaining what are LLMs. I'm just gonna like really just go super quickly over this part because I think 99% of people already know how they work. So I'll just like like make a short comment on that to make sure that everyone's in the same page. But like I believe that probably this is like general knowledge nowadays. So just super short introduction on like what are LLMs and what's the thing that's interesting about LLMs in the context of this presentation here. And then we'll move on to the real interesting stuff, which is the techniques that we can apply to detect generated texts. So like what are the tools that we can use? How do they work? That's what we are going to be dedicating most of the time to. So I'll imagine that like around 25 minutes, 30 minutes would go into this part here. Really interesting stuff. And then we are going to be speaking about how to just, evade the systems that detect generated text. So we are going to learn how to detect them. And then we're going to learn how to just go around the systems and avoid being detected, right? And it's going to make sense because like once we understand how the system works, it's kind of intuitive to understand how we can just evade the system. So common techniques, circumvention, and lastly, if we have extra time, we could get a bit into ethics, but to be honest, I usually don't have time to get into this part. So that's like the extra stuff that maybe we'll have at the end, but really, usually there's no time. So the interesting bits here are going to be the common techniques and the circumvention. But first, let me get started by having a 3-minute introduction about like what are LLMs and what's interesting about them in the context of this presentation. There's a lot of things that one could say about LLMs, of course, but I'm just interested in a very specific thing, which is that LLMs for us, for the thing that matters in this presentation, are just text predictors. So text predictors, like the one that you have in your phone, like when you're writing like a WhatsApp, it predicts the next word all the time. So for us, in the next 50 minutes, that is an LLM, okay? Just a text predictor, just something that guesses what's the next word that should come after the text that we have. So super short introduction, as I promised. I just wanted to like say this. I imagine that probably 99% of you know this already, but I just wanted to make sure that we're on the same page to be able to, well, follow along the presentation. So the difference between ChatGPT and your phone is that ChatGPT is very smart, has lots of parameters, etc., etc. A very big system trained on millions of, well, data documents. And your phone is not so smart. So your phone is like a small brain, right? Like a kind of silly predictor, but they work more or less in the same way when it comes to the fact that they predict the next word. Of course, they are different technologies, etc. But what's interesting to us is just let's predict the next word. So that's the introduction. That's what we need to know about LLMs in the context of the presentation. And now we are going to dive into the first interesting part of the presentation, which is the common techniques that we can apply to detect generated text. We're going to be speaking about 4 specific technologies here. Well, maybe just 3, but the 3/4 technologies that we'll be speaking about are kind of related, but different at the same time. Let me explain. One of them is a classifier. So probably all of you have like a notion of what is like a classifier, right? It's just a thing that tells us, yes, I think that this text is detected or, is generated, or no, this text is human, right? Just yes, no, that's a classifier. How do we train a classifier? We take lots of texts, we give that to a system, and we then run a training functions that tries to approximate a cost function, which is basically a way of saying that we just try to train a system to be able to identify what are the typical characteristics of a generated text. So we give lots of examples, millions of texts ideally, and we train a system that we wish will be able to identify when a text has been written by AI by looking into, well, different parameters. Like, for example, I know a basic thing could be the distribution of the different types of words in the text or whatever. You could come up with lots of different metrics and then just train a classifier on that. So classifiers, that's the first of the tools that we have, very basic, but it's one of the main things that exists. And I wanted to have a short comment on one of the systems that exists. You'll have that on your Mentimeter website. So you'll see that if you scan the QR code, you'll get a link in your phone/laptop to a website that is under the OpenAI domain. And when you go to that website, you'll see, I'll share my browser now. You'll see that you can, well, like get to this blog article speaking about a new system that, well, detects generated text, right? the thing and so what I wanted to show you here is that if we really try to click on the try the classifier button here. Oh, sorry, sorry, I shared the wrong screen. Sorry, my mistake. Sorry. I'm gonna share the right one. Yeah, okay. I hope you can see it now. So we are on the OpenAI website. This is their blog, right? And they were saying we have a classifier to detect generated text, etc. So we are here on the blog. And if we go down here and we try the classifier, we get to a page not found website. So the question is, why would I even want to share this with you? What's the point if you can't use the system, right? Well, the reason why I wanted to share this page with you is that they say it here, right? Like, due to its low rate of accuracy, the AI classifier has been discontinued. Like, it's not usable anymore. It's on Hugging Face, however, because like they shared that publicly, so you could still access the system. But I think it's very interesting and it raises more of an ethical question. The fact that you are OpenAI, you have trained a system that should be able to detect your text, the text that your system is writing. But at the same time, you are telling me that your system is not able to detect generated text. So, well, I think it just raises interesting questions when it comes to ethics. Because, well, we have lots of systems that can detect text, but if the research on detecting that text is not following the state of the art, maybe we will have a problem. There's a lot of things to say. I would love to leave that to the end of the presentation if we have time, but I just wanted to share this super short blog post with you. Now, I'm going to go back to the presentation, and I'm going to speak about a system that you can try. And this system is something that I love the name because it's very, very related to the name of the presentation. It's called Ghostbuster. So this system is just another classifier. What did they do? They just took like a lot of different metrics, tried to come up like with the ones that were like most indicative of when a text is generated, and they just trained a basic classifier. So you see like a logistic regression classifier. That's a very common type of classifier. So it's like really nothing fancy. Like it's just coming up with like metrics for this text looks generated because whatever. They just take like a bunch of metrics and they train a classic classifier. But it turns out that it actually works quite well and it's like really state of the art. This thing came out last December, I think, so it's pretty recent and it's a good system. Like it tends to work quite well. I'm just gonna show you for like 30 seconds how it works, but it's very intuitive. So you'll be able to see if you go to the Ghostbuster website that you just take a text, paste it, you ask the system, is it AI? And then it tells you, we'll get the results in a second. It will tell us, okay, I think it's 69% generated. This one is generated, but it just works like this, super simple to use. And it is a good system. If you do want to try to detect if a text is generated, this is one of the things I'd go for. I'll be sharing more resources with you, but this is a good system. So let me go back to the presentation once again. You'll also have the link for this tool on Mentimeter. And now you'll be able to see the presentation again. So Ghostbuster, a good system, state of the art, very interesting. Having said that, let me move on to the next technique, which is a thing that's called black box analysis. However, well, I don't know if you recall, but I said we're going to be speaking about 4 techniques. And then I said, well, actually, we're just going to be speaking about 3. The reason why we're going to be speaking about 3 is that I'm just going to skip over this part for the sake of time. Why? It's just not very relevant anymore. This type of techniques were relevant like maybe some years ago, but I would say that they are kind of outdated. So they don't work very well. So I'm just gonna skip over this part. If you're interested, I can try to, well, comment on that at the end of the presentation, but for the sake of time, I'll just move to another technique, which is a white box analysis in contrast to a black box. And this is very interesting. This is really interesting. And the first of the tools that we are going to look into is a thing I love. So we're going to look into this thing that's called GLTR. I'm going to share that with you. So let's just go to the website. You'll have it on Mentimeter as well. And if we take a look into the website, which you will be able to see right now, we are here. So GLTR, Giant Language Test Room. And what we have here is just, well, a text box where we can enter any text. So I'm just gonna select a demo text here. For example, a text that was written by GPT-2 with some parameters, generated text, all right? So I selected that text, I analyze the text, and when I do the analysis, I get this output here. So what's the thing that we are seeing right now on our screen? What we are seeing here is the distribution of the probabilities of each of the words or parts of words in the text. So, for example, I've been a gamer for over 10 years. During that time, blah, blah. When I hover over each of the words, you can see that this like bar plot is telling me, I think that with a 9.6% probability, the word that should come here is involved. So GPT-2, that's the system that we are asking here. GPT-2 is telling us, I believe that involved should be here. And that happens with basically all of the words here, right? All of the words in green are words that GPT-2 would choose to, well, just write in the text here. For example, multiplayer is not in the top 10 words. It's not green, it's yellow. So that means that it's the 39th. You can see it where it says top K position. It's the 39th word in the list of the words that GPT-2 would choose. But it's still likely. And that, well, will become more evident when we compare that to a human text. So here I've just chosen, well, an academic text, right? Like a piece of text from a scientific article. And what we see when we choose a scientific article is that, well, the distribution of the probabilities is quite different, right? We see red things or even purple things. So, for example, this word here would be the 8,558th word in the top of the tokens that we, in the top of the words that we could use here. So the idea, well, bottom line here is that if we see lots of words that are red or purple, then that means that the system, in this case GPT-2, wouldn't have chosen those words. So if GPT-2 wouldn't have made those choices, we can kind of infer that probably this text wasn't generated by GPT-2. That's the idea here. I love this tool because it's very visual. You can literally identify each of the words or parts of words, and it's, well, a really good way of being able to assess whether a text has been generated or not. Also, if you have, like, for example, a text that has different paragraphs, and some of them are generated and some of them are just human paragraphs, you will be able to see that as well, because you will be able to see that some paragraphs are completely green and some paragraphs are mixed. So great tool, and also allows us to visualize the idea that I was commenting on before. This thing of a language model is just a thing that predicts the next word all of the time. I think this becomes clearer when we see how it chooses the next word all of the time, right? So great tool, really great tool. Maybe a caveat here would be that the tool is from 2019, so it's kind of dated today, but I'd say it's still relevant. And also it uses GPT-2, so it's not like the most recent model, of course, but it's still relevant. It's still relevant because it, like, in general, all of the models tend to, well, write in a similar way. Of course, they are different, so they don't write exactly like in the same way, but they tend to make broadly similar choices of words. So if I write something with GPT-3, I would expect that a text written with GPT-3 would have, in general, more green words than a human text in general. So, as I said, not the most modern system, but it's still relevant. And I think it's a great way to visually identify whether the text has been generated or not. So, really great tool. I'd say this is probably my favorite. And well, I've shared the link with you, so feel free to just play with the tool. And I'm going to move on to a more modern tool, but that I'd say is less visual. So GLTR is the thing that we just tried, but there's a new version, I'd say, that is called Detect GPT. And this is, so if you just Google detect generated text, probably this is what will come up like as the first result. Detect GPT is, I'd say, an evolution of GLTR. So what's the how does Detect GPT work? It twists a little bit the behavior of GLTR. And what it does is what we can see here in this image. I just took it from the paper. So it has 3 steps. First, it perturbs the text. So that means it changes the words. Then it scores the perturbations. So it changes the words and then it gets a score for each of the changed versions. And then it compares the scores. I think that's not clear, like when I just say it like that. So I'm just going to give you an example of how this could look like. So more an analogy than an example, but let me just, yeah, give you the analogy. So I think it will be clearer. So when I speak, I don't know if I've made it in this presentation, but when I speak, I tend to use some words a lot. I think everyone does that, right? But the word I tend to use a lot is like. So like when I speak, I use that word a lot. And if you see a text and you see that it contains lots of likes, you will probably be able to tell that the text has been written by or spoken by me because it contains lots of likes. It looks like my text. So if you see that text, it looks like my text, but the idea that the TechGPT tries to do here is that it tries to perturb my text. So here you would have a text with lots of likes, a text that I spoke, and you would take that text and you would change some of the words. So for example, what you could do here is just literally rewrite each of the likes by, I don't know, like a synonym, so, or like, yeah, some synonym of like, right? So you would change all of the likes by another word. And then you have my original version and the other versions without the likes. So if you ask a scoring model, what's the probability that a text with lots of likes has been spoken by me? Then it would tell you, it's very likely. Probably this text has been written by Aldan because it contains a lot of likes. So I think that the text is generated by Aldan. However, if I ask the same model, do you think that this text that doesn't contain any likes and instead contain another word, do you think that that text has been generated by me? The system will tell you, no, I don't think it's been generated by Aldan because it doesn't contain any likes. And when Aldan speaks, he always used like. So of course, it's not his text, right? I think that's more intuitive. And then what we have, the last bit is the comparison part, which is basically just asking the scores. Was the original text much more likely to have been generated than the other rewritten versions? Here in the example of the like text, you would of course have a lot of probability with the original text, and then all of the other texts would have almost no probability of having been generated by me. So what you say is, if there's a huge difference, then the text, the original text, was generated. That's how the TechGPT works. I hope that the analogy makes it clearer. And that's literally the way that it works. So I'm just gonna like repeat it like with a proper example. You take a candidate passage here, a text, you rewrite the text, then you score the written versions, and if the original version was much more likely to have been written by an AI, then that means that the text was originally generated. I hope that's clear, and it's a great system. It is very good. It used to be probably the state of the art until some months ago. However, it's not so much anymore because there's an intrinsic problem with the detection of generated texts, and I'm going to dive deep into this part for a second because I think it's very interesting, and it like explains a lot about the difficulties of detecting generated texts in general. So there's a thing that's called the capybara problem. I didn't coin the term. This was like coined by a group of scientists that developed a system that is called binoculars. And those scientists, well, just put a name to a very obvious thing, which is that if I ask ChatGPT to ask to write something about a capybara that is an astrophysicist, I just prompt ChatGPT with this thing. What I will get is a text that talks about a capybara that is an astrophysicist, etc., etc. So of course this makes sense, right? Like I just asked about something and then I get a response about the thing that I asked about. That's completely normal. We have a conditioned probability here because I asked about a very specific thing, right? Like super specific, not a common topic. I didn't ask about football. I asked about a very, very specific creative idea that most people would not think about, right? I ask about that thing, I get a response about the thing that I asked about. The problem comes when I don't have the prompt. And this is what happens all the time, right? When I see a text without context, I don't know what the user was asking about. So if I just see a text that says, doctor, blah, 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 if I see this text and I don't know that the user was asking about a capybara that is an astrophysicist, I would say, oh, this text is very surprising. So probably an LLM wouldn't have been creative enough to come up with this text, right? Because it's a very specific thing. It's not a general thing. It's a very specific text. So that's the capybara problem. And this group of scientists here was the first one that tried to really deal with the problem. So they proposed a way to go around the issue. And I'm not going to be speaking about math, of course, but I would just love to comment on a very simple formula that they came up with, which is measuring two things: the perplexity and the cross perplexity of a text. The perplexity means, well, how surprising a text is to a model. So how surprising is this text to whatever model, right? If it is surprising, usually we would say, oh, it's not generated, because a model would not write this thing. And then what we measure, and this is the new thing that they introduce, is the cross perplexity. So what this is trying to measure is how surprising are the predictions that another model would make to the first of the models. So we have two models, and we try to measure how surprising the predictions on that text that a different model would make would be to the first one. That's a bit complex to visualize, I think. So again, I'll give you like an easier way to understand this thing. The idea here is that something can be surprising, right? So if something can be surprising, we want to normalize the surprise by how much would we expect to be surprised on that text. Again, example, we have the text, the capybara text, very surprising, right? We wouldn't be expecting to see this text here. So we can say that it has a high surprise or perplexity, or however you want to call it. It's very surprising. But this surprise, this high amount of surprise, comes because of two things. So it can be explained in two different components. It is very surprising because it talks about something that is very unusual. It talks about a capybara that is an astrophysicist. So it is very surprising in that sense, right? So that's what creates the perplexity here. And then there's in every generated text or written text, there's a part of the perplexity that comes because of the fact that it is written by a human or an AI. If it is written by a human, it will be very surprising. So if this text had been written by a human, we would see a lot of perplexity here. And because, well, in this example, it's been written by an AI, we see a low perplexity that belongs to this component of being written by an AI, right? So what we want here is to separate the two things. We want to not measure the general perplexity. We want to measure the part of the perplexity that is explained because this thing has been written by AI. Why do we want to measure that? Because if we are able to isolate this component here, if we are able to identify this part, then what we are able to do is that we are just able to say, okay, if this bar here is very large, then the text is human. If the bar is very small, it means that it's been written by an AI. So we want to isolate this part. How do we isolate this part? We use the formula from before. We try to normalize by the expected surprise of an LLM on that text. That's what we try to do. We try to isolate the part of the perplexity that corresponds to the text being actually written by an AI. I hope that's clear. Of course, these are, well, technical concepts, but I really hope I can like make them more accessible. And again, if you have any questions, feel free to ask. But having said that, I'll share the link to the tool with you, so you'll have it in your Mentimeter website. And I'll move on because there's a lot of interesting things to talk about, and I'm trying to be mindful of time. So let me just dive into the last of the techniques that we are going to be speaking about, which is a thing that's called watermarking. Watermarking, we all have like a notion of what it is, right? It's like I have like a mark that I try to embed onto something. So I try to put it like on a text, and that's how watermarking works in general. But how do we apply this to text? How do we put a watermark into a text in a way that is not visible to the user? So what we do is coming up with two lists. So you can just imagine, I take the dictionary, I open the first page of the dictionary, and I start marking the words. So the first word, for example, I would highlight that word in red, and then I would go to the second word and I would just paint it in green, and I would do that with all of the words in the dictionary. Red, green, red, green, red, green, all of the words, and then I would have two lists of words, right? I would have my red list of words and my green list of words. And what I do with that is that I tell the system, I tell ChatGPT, you can't ever write a word that is in the red list. So you are completely forbidden to write, for example, tree, house, park. You can't write those words. They are forbidden for you. You can't write them. And then the words that you can choose are green words. Car, street, etc. You can write those words. Why do we do this? Well, I think it's very intuitive that if we see a text that contains, for example, the word tree, then that automatically means that ChatGPT didn't write that text, because ChatGPT had a clear instruction for never ever writing that word, right? So we are able to clearly distinguish that thing. Problem. If we have two words that usually go together, so for example, Barack and Obama, and Barack is a green word and Obama is a red word, you have a problem, because you can't just say, oh no, you can never write Obama. What are you going to write? Barack car? It wouldn't make sense, right? So what we do is we just change the technique a little bit. We do a thing that's called weak watermarking. And the basic idea is, if you can choose like among like a broad range of words, then you should choose green words. But if you have no choice, if you need to choose a red word, you can choose it. That's what we do, and that's a great technique. Why? Because it's able to get rid of the capybara problem. Here, we just care about what are the types of words that we see on the text. We don't mind if it's surprising, if it's not surprising. That's not important, because if we know that if we see the word tree, that automatically means that the text has been generated. Sorry, has not been generated. So it's a great technique to get rid of this really pesky problem. But of course, watermarking is not so like great at the same time, because you have to apply it. You have to consciously make an effort to like force your system to use watermarking. Depending on how you do it, it could decrease the quality of your text. Also, it's not like a systematic thing, right? Like every individual could apply a different watermarking, so you don't have a way of just seeing a text and saying, oh, it's been generated, because like there could be a watermark for ChatGPT, a watermark for, I don't know, Gemini, etc., etc. You know, so it's a great technique, but of course there's downsides to it as well. Having said that, it's generally a good technique and probably the most solid one. And I would just love to give you some, I don't know, tricks, some hints on how you could try to identify generated texts without using any tool. So just looking at the text, right? Manual things that you can try to do, because I think they are sometimes even more reliable. One of the things that we could try to think about is, let's try to see if, I don't know, to analyze the types of words in the text, right? For example, maybe ChatGPT would use a lot of verbs and a human wouldn't use so many. Well, as you can see here in this graph, that doesn't really work, right? So ChatGPT, a human, they tend to use more or less the same distribution of types of words. So that doesn't work. But something that works, for example, is the writing style. If I'm asking like a child to write a text and I start seeing lots of very formal words, high level stuff, you know, like, I don't know, like really proper words, you know, like words that a university student would write, then I can instantaneously say, okay, you didn't write this text. Maybe it doesn't necessarily mean that it was like an AI generator that wrote the text, but it gives us a hint on that person didn't write the text. I think this is common sense. Like it's not anything that's technical, but it's just common sense, right? Also, another thing is that, for example, if you are reading a text that is written by a British person, but it contains American words, of course, that, well, gives you like a hint into probably it's not the person who wrote this thing. So dialects, that's a mistake that some people make. Also typos, if you see typos on the text, usually that would be because it was written by a human person. Of course, you could just like insert typos on the text, right? But in general, those types of things tend to point to a human writing the text. And one of the things, and this is like, if you see this thing, it's really the number one hint, and like really just gives you like a very strong idea of this text has been generated, is when you see hallucinations. So when you see things that are contradicting common sense, or facts that you just know are wrong, or for example math, if so, language models are especially bad at doing math. So if you see the model is saying 2 plus 3 equals 19, probably the text has been generated, right? There's other types of errors that those systems make, but really bad math, encyclopedic errors, or common sense errors, those are great pointers to the text having been generated. So, last point here, as humans, we are very bad at identifying texts. Like we are really, really bad. Basically, you would get more or less the same accuracy if you just flip a coin, or if you ask a human person. So keep that in mind, because it's very hard to detect generated texts like manually. But I think those things are common sense and sometimes could like just help us to identify those things. So first part of the presentation closed. we now have an idea of how detectors work. And I think that will help us to instantaneously understand how to go around those systems. That's what we are going to get into right now. But before I tell you how to do it, I think that if I were to ask you right now, do you think, what do you think, how do you think that those systems can be evaded? What would you come up with? And maybe, Frank, I don't know if I can ask you, what would you say if you had to come up with something? Like,
Yeah,
how would you change?
I will maybe try to do what you said with the surprise. So to introduce some words, maybe that will be like a surprise. So the mathematical formula will just not work at this, because
yeah, that's very smart idea indeed. It's great. It's great. So you would try to rewrite the text, right?
Yeah.
So you would try to introduce some different words to just change the distribution of the probabilities and to make them look more human, to like confuse the detector. Paraphrasing. That's what we need to do. Indeed, the idea, well, I think is pretty self-explanatory, but like I have a text, I take a system that changes some of the words in the text, and I get a new version. The first version would be identified, the new version can't be identified, just by changing words, right? That's what we should try to do. Now, the question is this really effective? How effective can it be? Well, here in this table, what we can see is that we have a detector that was used, well, to like detect a set of generated texts. And it was very accurate. You can see that it had a 97% accuracy. That's great. That's fantastic. However, you will see that I have masked these parts here. So those are the numbers when we try to paraphrase the text. And I have masked them because I would like you to think for a second about how much do you think it can drop? And you will also see that I have pointed you to this column here. So you will see that the perplexity, the surprise, is lower, like considerably lower here, with respect to the surprise that we have when we paraphrase. So that brings back the question to what you were saying before, Frank. You just increase the surprise, right? That's what we are doing here when we paraphrase. The question is, how much would it drop? And actually, the answer is, well, very bad for some and very good for others. It completely breaks the system. So we have a 57% accuracy when we do paraphrasing properly. And when I say properly, I mean that we really change the text. Like, it's not just changing a few words, we really rewrite the text. When we do that thing, we basically just destroy the system, because some people would say, okay, 57%, that's at least like, well, more than 50%, right? But no, that's horrible, because if you have a coin that has a 50% accuracy, so like the minimum for any system, the minimum for a random classifier is a 50% accuracy. Here we have a 57%. It's completely unreliable. Like, we can't trust the system. So the idea here is, if we rewrite, if we paraphrase, we just destroy any system that like tries to detect texts. Of course, that changes between like the different systems that like you could try to study, but in general, paraphrasing is a really effective technique. It's the thing to do. And how do you do that? Well, I'm gonna just share some links with you. You will see them on Mentimeter now. So I'm not gonna go over all of them because there's a lot. And if you search on Google, you will find really tons of them. So just search on Google, rewrite text, I don't know, to avoid detection or something like that. you will get to all of these websites that I'm just showing you right now. Indeed, there's a lot of them. But if I have to point you to a specific one, I would point you to my favorite, which is DeepL-Write. Why DeepL-Write? Well, I'm gonna actually show you here. So let me just share my browser again, because I think this one is a really, really great tool to write text. So I'm just gonna take a text that was generated by GPT-2. I'm just taking this as an example. And I go to DeepL-Write and I paste it here. So DeepL-Write, the great strength of DeepL-Write is that it allows me to interactively change the text. So like it gives me different possibilities for the phrases that I can choose, right? So you see, like I don't know, just change the phrases in any way that I like, but I can also go to individual words and change them. And that's a great way to just rewrite the text, because like with most other models, you just like give the model a text, get an output, but if you don't like it, you have to manually go to the output and start writing things yourself. Here, it's interactive. So you can really choose how you want your version to be rewritten, and that's a great advantage of this system. So if you have to write, I say go for DeepL-Write. Great system. I'm gonna go back to the presentation, and we're getting to the last bit right now. I'm just gonna finish by giving you some manual tricks. So some things that you could try to do to evade the systems, right? One of the main ideas is to give as much context as possible. So if I were asking ChatGPT to write a text for me, I would like tell ChatGPT, write as if you were, I don't know, like just let me give you an example. A university student that's trying to write an essay about the, I don't know, War of Independence of the United States, right? So write as if you were a high school student. You have to write a text about the War of Independence, blah, blah, blah. All of the context that you can give. This helps a lot because it gives the system hints on what dialect should I use, how should I try to model my speech? So should I try to write as a high school student or as a university student, etc., etc. As many data points as possible, so as much context as you can give, that really helps. Also, if you ask the system to use active voice, that's really, really beneficial. And when I say active voice, what I mean is that some systems tend to write in the passive voice. Passive voice is something that you would see, for example, in scientific articles. 500 patients have been studied for associations with cancer, phrases like that. That's passive voice, and it's it's an important chunk of the training data of LLMs, because like scientific articles and legal texts, etc., there's a lot of them. They are very available. So those systems are trained on those texts very much. And if you try to use the active voice, you get two things. First, the text just sounds more personal, of course. And the second thing is that you also skew the distribution of probabilities a little bit. So that, let's say, contributes to the capybara problem. So as much context as possible, active voice, also give specific data. This helps to avoid to just avoid hallucinations, and also contributes to the context giving thing I just spoke about. So it started in this year, it lasted for how many months, whatever, like just give as much data as you can to the system. That really helps. Then avoid quotes. And I don't mean avoid quoting other works. So for example, if you are writing a scientific article, of course you need to quote your sources, right? I'm not speaking about not quoting other pieces of work that you used. I'm speaking about avoiding literal quotes. So for example, if I'm writing this essay, I could start saying, George Washington said one day, whatever. I don't have a quote in mind right now, but you know, like some people just say, George Washington said, or Albert Einstein said, whatever. Those things are very, very bad for you when it comes to the text looking human. Why? Because so if you remember the example of GLTR, the main idea was that if you see a lot of green things, that means that the text has been generated. If a system has been trained with a lot of examples of Albert Einstein said blah blah blah, then the system is so used to seeing that thing that when it's like starts seeing the quote, it completely knows what's going to come. It knows the quote already, so everything will be 100% green of your quote. So even if you were not copying, like, or if even if you were not generating the text, if you include quotes, it can make the text look generated, even if it wasn't. So try to avoid quotes, like quotes and also legal texts, because legal texts, again, are a big part of what goes into those systems. So it will not help you. So avoiding quotes, avoiding legal texts, also outlining the structure. I want you to start making an introduction about whatever. Then you will write about the effects on society of the Independence War. Then you will make a conclusion speaking about blah, blah, blah. If you outline the structure, you are kind of trying to leverage the capybara problem, because you are making the system use a very specific way of writing. You're not just asking about write about the Independence War, you're just asking the system to write about the Independence War in a very creative way, right? So outlining the structure, context, etc., very important. Then, if you can, I would write the beginning of the answer. For example, I tend to use like a lot. So if I write the first paragraph, the system would be able to pick up that I tend to use like a lot. So the text will just look a lot more like me. That's the idea here. Write the first, I don't know, 1, 2 paragraphs, and it could help the system. Use other LLMs. There's Gemini, Claude, Hugging Face, Chat. I don't know, like there's literally like lots of LLMs that are not just GPT. So you can like try to use other tools. Also, if you don't use English, if you go for German, for example, that's much, much harder to detect. Why? Because like the systems have been primarily trained in English, so it's just much harder to tell that. Also, there's some transformations that you could try to do, like for example, I don't know, changing some words by emojis or things like that. That could potentially confuse the detector a little bit. And one other thing is that if you are going to rewrite, the first 50 words are the most important bit, because most of the systems take a shortcut. They don't analyze the whole text because it takes a lot of time. They just look into the first paragraph, first 2 paragraphs, and they assume that the text is generated or not based on that. Last thing, once you have rewritten your text, go to websites that detect generated texts, like Undetectable. You just paste your text and it tells you, I think it's generated, I don't think it's generated, and then just iterate all over again. It's 1 hour already, so I'm gonna stop here. I don't have time for ethics as I was expecting. but I'm gonna leave you with some links for further reading, so you will get that on Mentimeter. And one of the things that I would love to ask you to do, if you can, and I would really thank you if you can, fill in a super, super short, like 10-second form. Just tell me, what do you think about the presentation? So did you think that the technical level was all right? Did I explain things properly, etc., etc.? If you can fill in the form, that really helps me a lot, and I really take a look into the answers. Also, if you fill in the form, there's a small surprise in the end. So when I say surprise, it's just a link to something. Don't get too excited, but if you can fill the form, I would really thank you. And well, it's 1:25, right? So sorry, 2:25. So that's the end of the presentation. I really hope you enjoyed it and you learned something new.
It was a really, really good presentation. I liked it very much. It was really, really cool. And really cool to see how generated text can be detected and what countermeasures you can take. I enjoyed it very much. Thank you very much for this presentation.
May I ask you a question?
Thanks a lot, Frank.
Yeah, can you hear Klaus? Or?
Can you hear me, or should we change the microphone?
Yes, I can.
Oh, okay.
Yep.
I have one question. A lot of people are doing, like you recommended here, over time, these documents will be stored also somewhere, right? So will that change this logic over time?
Okay, maybe if you could get closer, because I thought I could hear, but actually it was.
I can repeat what Klaus said. So Klaus said that many people are using the countermeasures you were suggesting. The documents that they will produce with this will also be somewhere, maybe on the internet or somewhere, because you're generating text for purpose, right? So, and his question was that will these countermeasures over time will not be as effective as now, because this text will also be used for learning of the large language models. What was the question, Klaus?
Well, actually, so that's a great question. That's a great question, because it links to one part of the presentation that I just didn't have time to go through. So let me go back some slides.
Yeah.
Because I think this slide, so if I have to remember one slide in the presentation, I would remember this one. Here, well, so I took this quote from a scientific article that tried to analyze in general if we are going to be able to detect texts in the future. And what they did, they just did something very simple, really. But like they took, like, I don't know, some pages of literal math theorems and proofs to prove a point. And the point was, when these systems get better, so when LLMs learn more and more and more, they will be able to, well, write a lot more like humans. Right now, they are not perfect, right? So we are still able to identify generated text because they are not able to write 100% like a human. But what this scientist said is, all right, this works right now, but at some point in the future, when those systems get better, and they will probably, we are not going to be able to identify the text. And I think that's a very important idea. And I mean, I think it's kind of common sense, right? Like, as they get better, it will be harder. But it just leaves us with a bit of, I don't know, unsettling thought, which is, what are we going to do in the future? We are not going to be able to detect text in the future. So I hope that kind of addresses your question.
I think so, Klaus. Okay. Mm-hmm. Yeah. So, but on the other hand, if we think about, for example, computer-generated graphics, right? If you have the computer-animated graphics, which is really, really, really good at the moment as well. Sometimes there is a little bit where you see, well, I see this, but it looks too perfect. You know what I mean?
Yeah.
So
yeah. I mean, that thing is really, like, right now I would agree with you, right? Like, many times it looks too perfect.
Yeah.
But I think over time those systems can learn to be a bit more imperfect.
Yeah.
And it's really hard to deal with those things. Like, those scientists just proved mathematically speaking that it's going to be impossible, and I really think it is. There's some people who came up with a last resource. So some scientists said, okay, don't worry, even if like it's going to be impossible to detect those texts, there's something that we can do. And they said, what we can do is we can just create a database of all of the answers that ChatGPT has given in history. So literally every single answer, we're going to store that in a database. And then if we want to know if a text was generated, we just go to the database and we see if it's there. Is that viable? I don't think so, because it's not like you have lots of different systems. Anyone can generate texts at home. Well, maybe not right now, but like it's very hard to control AI in general. So you can't just create a database of generated texts and use that to control everything, you know? So my point here is that really it's going to be impossible. Computer graphics, yes, they are not 100% there yet, but I would expect that they will keep improving. And yes, it's a hard problem to deal with.
It's true. Okay. Any other questions? One. Okay, so thank you very much again, and it was a great presentation. And yeah, thanks for being here with us in Lüdinghausen, at least virtually.
Thank you. I really thank you. Like, I would love to be there in person, but it was just too hard to go. So yeah. Thanks a lot, and I really hope you will learn something. Anyway, if you want to connect with me on LinkedIn or something, that was the surprise at the end of the form. So I'll leave you with that, and have a great rest of the day.
Thank you very much. Bye.
Bye. Bye-bye.